Hello, this is Rolf. Welcome to the video lecture series on the course of building construction. So we are going to follow the syllabus given by the State Board of Technical Education, Patna, Bihar. So in this video, we are going to see what are the different building components and what are different types of structures available in the field of construction. These are the different topics we are going to cover in this video. First one is building component and their function. Second is substructure. Third is superstructure. And finally, we will see what are the different types of structure available in the field of construction. First, we start with the building components and their functions. So this diagram shows what are the various components available in a building. So majorly, the buildings are divided into two components. One is substructure, other one is superstructures. So in these two categories only, every other components included, whether it is a foundation or a wall or a roof or a door, everything lies either in a superstructure or in a substructure. So substructure means it is a part of a building that lies below the ground level or plinth level. The superstructure means the part of a building lies above the ground level or a plinth level. So we start with the substructure first. So substructure is a part of a structure lying below the ground surface, such as foundation of any type is known as substructures. Mostly these substructures are foundations and the plinth beam. Why? Because foundation is lies below the ground level. Okay, so the foundation, we will build the foundation below the ground level, and plinth is also we will build below the ground level. So we will call these two as a major components in the substructures. So why we are using these substructures means these substructures are used to transfer the load safely from the superstructure to the ground. So we'll see a foundation. So foundation is a substructure of a building. So the foundation is the lowermost structure in any building. So it is the lowermost structure in any building. It will transfer the load from superstructure to the soil. So it collects all the load from every component, that is the roof or floor. Every load from the superstructures are transmitted to the ground or the soil by means of foundation. What is the functions of foundation? The first one is the reduction of load intensity. So this foundation can distribute the load of the superstructure to a larger area. So what will happen? So the total intensity of the load doesn't exist the safe bearing capacity of the soil. So if the safe bearing capacity of the soil is exceeded by the total load intensity, the structure will fail. Okay, so to reduce the total load intensity, the foundation distribute the load of the superstructure to a larger area. And the second one is even distribution of load. So the foundation can distribute the non-uniform load of the superstructure evenly to the subsoil. So if a foundation can transmit the load evenly to the subsoil. So not an uneven distribution, it can evenly distribute the load to the subsoil. And the third one is provision of level surface. Foundation provide a level and hard surface over which a superstructure can be built. Okay, this foundation will give the leveled and hot surface so that we can raise a superstructure on the foundation. And the fourth one is lateral stability. So it anchors the superstructure to the ground, thus imparting stability to the building. So once the superstructure is anchored in the foundation, that is, if you are erecting a superstructure from the foundation, it will have the lateral stability to withstand. Okay, and the fifth is safety against undermining. The foundation provides safety against undermining or screening due to burrowing animals and floodwaters. So some animals, they will build their homes inside the ground. So what will happen, that then the soil, it won't be compacted too much, so it will have a loose holes. So if you build a building over that, it have a chances to fail. So to avoid all these things, what we are giving the foundation. So the foundation, it will save the building from the undermining. And the last one is protection against soil movement. Some special measures prevent or minimize the cracks in superstructure due to expansion or contraction of subsoil. So it will protect the building against the soil movements, underground soil movements. It can provide a protection. Okay, these are the functions of the foundation. And the plinth beam, this plinth beam is basically provided to distribute the load uniformly to the foundation. See here, the foundation is completely below the ground. So this is a foundation, this is a plinth, this is a plinth. So the load from the superstructures are to distributed to the foundation. So without the plinth beam, what will happen? Sometimes the load distribution may not be equal in all the foundations. Suppose this is one foundation, this is a second one, and this is a third one. Without the plinth beam, the first foundation may get higher load intensity. So due to the higher load intensity, what will happen? That foundation may go to the settlement. If the one foundation goes to the settlement, it will affect the whole structure. So to avoid that, we are giving the introducing plinth beam in the structure to distribute the load evenly to the foundation. So due to the even distribution of the load, we can prevent the settlement of the foundation. So here, see here, this diagram, this one is a plinth beam and this is a column. So plinth beam is a substructure, whereas column is a superstructure. So from the plinth beam, the superstructure is going to come. So we can say this plinth beam is a transition component, because the superstructure and substructure meets in the plinth beam. Next is superstructure. So we already know what is a substructure. The substructure is a part of structure that is below the ground or plinth level. So the superstructure means it is a part of a structure that is above the ground or plinth level. Generally, columns and walls are constructed in the superstructures. So there are some important parts of the superstructures, that is walls, sill, lintel, doors, floors, roofs, parapet, beams, columns. So we will see these important parts by one. So we already saw this picture. It shows the different components of the structure. So we will see them one by one. Okay. The first is wall. So in a building, the first thing we saw is a wall. We can't see the column, we can't see the doors or everything. We can see the walls. So the wall in a structure that gives a defined area of a room, or it carries a load. In some structures it carries a load also, and mostly it gives us some privacy to us. Okay. And there are two kinds of walls. One is a load bearing wall, another one is a non load bearing wall. Load bearing wall means it carries some load to the foundation. Non load bearing walls means it doesn't carry any load. The load-bearing walls will be used in load-bearing structures. The non-load-bearing walls will be used in the framed structures. So the walls in the building that form a fundamental part of the superstructure or separate interior rooms, sometimes for fire safety. Next is sill and lintel. So these sill and lintel will present in a window or door opening of a building structures. We can see them both in a single window and a door opening. So if you have a door opening or a window opening, the bottom structure of the window or door opening, we call it as a sill. The top structure of the window or a door opening, we will call it as a lintel. Okay, this is the sill and the lintel. Next is door. So door is a movable barrier secured in an opening. This opening may also known as a doorway. So why we need a door is it gives an access to go inside of a building or inside of a room. So without door or door opening, doorway, we cannot access to the building or a room. A door is held in position by door frames, the members of which are located at the sides and top of the building or doorway. So see the diagram here, we can find the different members which is required to fit a door in a opening, like hinges. See here, hinges, jam we needed, casing we needed, threshold we needed. So it is a different components of a door. Okay. Next is window. So a window is a ventilated barrier provided in a wall opening. Door is a movable barrier secured in an opening, whereas window is a ventilated barrier provided in a wall opening. So why we need a window means to admit light and air into the structure, and also to give outside view the persons living in the building. Some the windows also increases the beauty appearance of building. And floor. So floor in building constructions is a leveled surface which can support the objects or occupant present in the building. So there are several types of flooring materials. One is a cement or lime concrete, brick, flagstone, marble, glass, ceramic, plastic, mud, and moram. These are the different types of flooring materials used in the field. Next is roof and parapet. A roof is the uppermost portion of the building. This roof protects the building from heavy rains, heavy wind, or sunlight. There are various types of roofs available in the field of construction. One is a flat roof. Flat roof means it is a flat surface on the top of the building. Second is a pitched or sloped roof. At the top of the building, we will have a sloped surface roof. Third one is a roof shells and folded plates. Next is a parapet. So this parapet wall is constructed is on an extension of the wall at the edge of a roof, terrace, balcony, walkway, or other structures. This parapet wall will act as a barrier to protect the human beings or living things fell from the structure. We see about beam. So beam is a horizontal component of a building structure. So here it is a beam, it is a beam. It is a primary beam, this is a primary beam, and this one is a secondary beam. So these beams can be made upon steel or reinforced cement concrete. So why we need a beam in a structure, or what is the function of a beam? These beams can support the load of a building structure. It can support and transfer the load to the column of a building structure. Second, it takes tensile load of the structure. It doesn't take up the compression load. It takes the tensile load of the structure. Next, a column. So beam is a horizontal component, whereas column is an vertical member or component of a framed structures. These beam can be in framed structure as well as in the load bearing structure, whereas column is available in the framed structure, okay, not in the load bearing structure. So it is a vertical member or component of a framed structure. This column may be made up in reinforced cement concrete or steel columns. So what is the function of the column is it's distribute the load to the foundation, and it takes the compression load of the structure. So beam it takes the tensile load, whereas column it takes the compression load. The next heading is type of structures. So we have three types of structures. One is load bearing, another one is a framed structure, and last one is the composite structures. So the load bearing, mostly every load is carried by the bricks. Every load is carried by the bricks column. One beam is only the RCC material, whereas that column is made up of brickwork. Whereas the framed structures, the beams, columns, everything will be in the RCC or in steel structures. The composite is we can build a steel structure and a RCC structure in a same building. That type of building we call it as a composite structure. What is a load bearing structures? What are the uses of load bearing structures? So in the load bearing structures, loads directly transfer to walls. Then the wall transfer load to soil. Then this load bearing structure is suitable up to 2 stories only. If we go beyond 2 stories, the structure cannot be stable. So you have to go with the framed structure or composite structure. These load bearing structures, where we can use this load bearing structure is this construction is adopted where hard strata is available. Okay, this is a load bearing structure. Next is a framed structure. So how the load is transferred in the framed structure is, first the load is transferred through a frame of slab. Then from the slab it will go to the beam. From beam it will go to the column. Then column to the footings. Footings means foundation, and the foundation to the soil. In the framed structures, walls do not carry any load except their self weight, whereas in the load bearing structures, walls transfer the load to the soil. The framed structure, walls do not carry any load. These framed structures can be used in a multi-story building or more than 100-story building. We can construct it using the framed structure. The last one is a composite structure. The composite means it is a combination of load bearing and a framed structure. So this will have the every advantages of the load bearing as well as the advantages of the framed structure. Okay, we summarize what we saw in this video. The first we saw about the building components, that is substructure and a superstructure. Substructure is a structure that lies below the ground or a plinth level. So in this substructure, the major two components are foundation and the plinth beam. Foundation is the lowermost component of a structure. It is used to transmit the load from the superstructure to the soil, and plinth beam, it is act as a transition member which connects the superstructure and a substructure. Then we saw the superstructure. Superstructure, the structure lies above the ground or a plinth level. Mostly the superstructures are columns and beams, and some other important components in the superstructures are sill, lintel, walls, doors, windows, floors, roof, parapet, beams and columns. We saw everything in the videos. Then we saw the types of structures. There are three types of structures. One is load bearing structures, another one is framed structure, and finally composite structures. So load bearing structure, walls can carry the loads to the soil, whereas the framed structure, there is no walls can carry the load to the soil. Composite structure is the combination of both load bearing and the framed structure. And there is some of the references book I referred for these topics. First one is D.N. Jones, S.K. Dongle, S.P. Arora. These are the some of famous books to refer in the building construction.